Okay, this section is, this is 8.6 about quadratic inequalities and rational inequalities. Okay, in this case, okay, inequality is, the function, a function is less than or greater than. So, okay, let's check the definition of critical numbers. Okay, critical numbers of a function is set the function equal to 0. Set the function equal to 0 and then solve for x. Then since the function is 0 and these x values are x-intercept, so we call all the x-intercept, the zeros, right? Zeros of the function. We call it zeros of the function. So zeros of the function is x-intercept. So for example, x equals 1, then, okay, for example, f of x equals x plus 2. f of x is x plus 2. The zero of this function is set the function equal to 0. So f of x equal to 0, so that x plus 2 is equal to 0, then x is negative 2. As we set the equation to 0, that means y value is 0, so that negative 2 is the x-intercept. So if we rewrite it on an x, number line x, this number line x, and this is negative 2. So negative 2 is the 0 of the function, which is the x-intercept. So if x is greater than negative 2, then what is the sign of the function? If x is greater than 2, okay, just plug in any number. If x is, let's say, 0, then 0 plus 2. 0 plus 2 is positive, right? So the y value, if x is greater than negative 2, then that is positive. What if x is less than negative 2? So x is negative 2, less than negative 2. Let's select negative 3. Then negative 3 plus 2 is negative 1. So the y value is negative. Okay, so from the critical numbers, we can find the sign of the function, whether it's positive or negative. So critical number is used to find the sign of the function for each interval. Okay, let's try example 2. Okay, to solve this quadratic inequality, okay, why don't we set the function is equal to 0? So set x squared minus 5x is equal to 0. Okay, so assume that, okay, replace this inequality symbol is equal to 0. Replace it with the 0. Then solve for x. Then x, factor the left-hand side of the equation. Then x equals 0 or 5. So 0 or 5 is what? It's the x-intercept. So draw a number line. And plot this point from lowest number. So this is 0. This is 5. So these two x-intercepts, or these two zeros of the function, gives us three intervals. One is less than 0, and one interval is between 0 and 5, and greater than 5. So for each interval, let's find the sign of this expression, x squared minus 5x. So let's select any point. So from this interval, okay, let's select any point. Let's say negative 1. Okay, let's use a negative 1. Then negative 1 squared minus 5 times negative 1, that is 1 plus 6 is 6. This is positive, right? Positive. So this will be positive. If x is between 0 and 5, okay, this is equal to this guy, right? So from this, between 0 to 5, so why don't we select x equals 1? X equals 1, then 1 is, okay, 1 times x minus 5. So 1 is plus, and then 1 minus 5. Okay, 1 minus 5 is negative, right? Negative. So positive times negative is negative. Okay, how about this interval, greater than 5? X is greater than 5. Then let's try the sign of this expression. So if, let's say x equals 6. 6 is positive, right? 6 is positive, times 6 minus 5 is positive. So positive times positive is positive. So from here, we are looking for the graph whose y value is less than 0. Less than 0 is negative, right? Negative. So these three intervals have y values when x is between 0 to 5. So this is the solution. That is the solution. So x should be what? Between 0 and 5. Since there's no equal sign, we don't include the end point 0 and 5. Or you can write it in interval notation starting from 0 to 5. They are parentheses, right? Parentheses, not bracket, parentheses. Okay, so this is how we can find the solution. So in order to find the solution, what is the first step? First step, change the inequality into what? Equal sign. Then solve the equation. Okay, then, so this will give you what? This will give you the zeros of the function, right? Zeros. Okay. Let me write x-intercept. This will give you the x-intercept. X-intercepts. And then plot. Number 3 is plot the x-intercept on the number line. On the number line x. Alright, then what do we do? For each interval, so in this case there are 3 intervals, right? 3 intervals. For each interval, find the sign of, the function y. Find the sign of the function y. Number 5, done. Select. Then we select the interval, right? Select the intervals or interval that satisfy the inequality. Okay. So first, change this less than or greater than inequality into equal sign, and then solve for x. So we have 2 values of x. So there are 2 x-intercepts, 0 and 5. So plot 0 and 5 on the number line x. Then we have 3 intervals. Then from each interval, find the sign of the y, the function. So we have plus minus plus. So plus minus plus. We are looking for less than 0. The function is less than or equal to 0. So find the interval where the sign of the y is negative. So that is the solution. So we're going to set this one as what? F of x. Okay, so set this expression equal to f of x, y equals something. All right, so then let's do another example. Okay, for this example 3, we're going to solve this inequality. So first, set the right side of the inequality is 0, or left side is 0. So let's move 12 to the left. So we have this. So the left side of the equation, let's set this is equal to f of x. Right? And then set this f of x equal to 0. Set the function equal to 0. So 5x minus 12 is equal to 0. Okay, so set the inequality is equal to 0 and then find x. Since this expression is equal to 0, then this expression f of x, y, and y is 0. So all these x values are what? X-intercept. Okay, so from here, let's find the combination. So x times 2x. 12 is 3 times 4. 3 times 4, right? 4 times 3, Okay, 4 times 3, and the minus sign here, then this is 8x minus 3x, sum is 5x. So the left side of the equation is the product of x plus 4, 2x minus 3 is equal to 0, then x equals negative 4 and 3 over 2. Set this is equal to 0 and this binomial equal to 0. So we have two x values. And these are the what? X-intercept. So on the number line, plot these two numbers. So negative 4 goes to the left, 3 over 2 on the right. So there are now, we have three intervals. One is less than negative 4, and then between negative 4 and 3 over 2, and greater than 3 over 2. So let's check the sign of y, the function, for each interval. So in this case, let's use, okay, this trinomial is equal to this product. So why don't we use this product? Because the sum is, we can find the plus, positive, or negative easily. So negative 4. So let's try negative 5. Let's try x equals negative 5. Then, okay, here is x plus 4, 2x minus 3. And then let's find the sign only. So if x is negative 5, then this will be what? Negative 5 plus 4 is negative. So negative 5 is negative 10 minus 3 is negative. So negative times negative is positive. So this one. So positive. How about between these 2 points, negative 4 and 3 halves? Okay, so why don't we try in this case 0? X equals 0, then what? 0 plus 4 is positive. 0 minus 3 is negative. The product is negative. So the sign between these two numbers is negative. Okay, how about the third interval? Third interval is greater than 3 halves. So let's try 2. X equals 2. Then 2 plus 4 is what? 2 plus 4 is positive. So 2 times 2 is 4. 4 minus 3 is positive. So the sign is positive. All right. And then if x is negative 4, then y is 0. X is 3 halves, then y equals 0. So we are looking for what? From this, greater than or equal to 0. Greater than or equal to 0 means positive. So the positive part is this one. So if x is less than negative 4, then the y is positive. Also x is greater than this number, 3 halves, y is positive. Alright, and then there's equal sign. Equal sign, that means we include the end point. So the solution is what? X is less than or equal to negative 4. Or x is greater than or equal to 3 halves. This is the solution. Or we can use interval notation. So negative infinity to where? All the way to negative 4. And then negative 4 is included. Or means union. X starts from 3 over 2 included all the way to the right. So this, we can write the answer in this way. Okay, in this example, okay, let's check the first one. Okay, x squared plus 2x plus 4 equals greater than 0. That is greater than 0. Then let's find the critical numbers. So let's set this is equal to 0. Then x times x, 2 times 2. Well, can you find the x-intercept? In this case, it is hard to find the x-intercept. So why don't we use the discriminant? The discriminant is what? B squared minus 4ac. So b squared is 2 squared minus 4ac. Then this is equal to 4 minus 16. So that is negative 12. The discriminant is negative 12. You know, since the discriminant is what? You know, negative b plus or minus square root of negative 2 over 2a, right? That is the solution. Then since this is the square root is negative and the discriminant is negative, this means there is no real solution, right? No real solution. So there are what? A complex solution. Complex solution, right? No real solution. No real solutions. So that means on the x-axis, we don't have x-intercept. This means no x-intercept, right? No x-intercept. No x-intercept. Because there's no real solution, no x-intercept. And the graph is what? The leading coefficient is positive. The graph looks like concave up, right? Concave up. No x-intercept, and then it looks like concave up, right? Because the leading coefficient is greater than 0, the graph is concave up, and then there is no real solution. That means no x-intercept. So that graph looks like this. So in this case, we can say that everything is greater than 0, right? So the y value is positive always. The y is positive always. So we can say the solution is what? Okay, the graph of this is above the x-axis. So y value is always greater than or equal to 0. Let's say this is equal to y, right? Then y is what? Y is greater than 0 always. So, x can be any real number. So x is all real numbers. Make sense? So whatever the x value is, the y value is always greater than or equal to greater than 0. So this is the case where the solution of this inequality is all real numbers. Okay, then let's check the second one. So let's set the function is equal to 0. Then this is equal to x times x, 1 times 1, the cross multiplies 2. So this is equal to x plus 1 squared is equal to 0. So x equals negative 1. Right? Negative 1 is the x-intercept. All right. Then what is the sign when x is less than negative 1? Okay, x is negative 1, then what? Okay, let's try using different color. X is negative 1 from here. So this is equal to this guy, right? So let's use negative 2. Then negative 2 plus 1 is negative. Negative squared is positive. Right? Let's say x equals negative 2. Then x plus 1 squared is what? Positive, right? Positive. Because something squared is positive. If x is greater than negative 1, so let's use x equals 0, then what? 1 squared equals 1, which is positive. So this is positive. So the graph of this is all positive, right? If x is negative 1, then y is 0. X is 1, then y is 0. If x is less than negative 1 or greater than negative 1, then the y value is positive. And this one cannot be less than 0. As you can see here, there's no negative value, right? Negative y value. So in that case, there is no solution for this inequality. And actually this graph is this one. This is the graph because the leading coefficient is greater than 0, and then when x is negative 1, y equals 0. And then it's concave up. So this is the graph. As you can see here, there's no y value that goes to the negative value. So we cannot find any x values. So no solution. Okay, how about next one? Okay, in this case, so let's set the trinomial equal to 0. And then we can factor this one. So let's find the discriminant. B squared minus 4ac. The discriminant is 3 squared minus 4ac equals 9 times 9 minus 20. That is negative 11. The discriminant is negative, so this one is same as the first one, right? Similar to first one. There is no real solution. This means no real solution. Let me write it. Okay, that indicates no real solution. So this means no x-intercept. Right? No x-intercept. And then since the leading coefficient is greater than or equal to 0, the graph looks like this. Concave up, right? Concave up. So on the number line x, there's no x-intercept, and it looks like concave up, right? Concave up, like this. Then, look at the inequality. The inequality is less than 0. This is the graph. And this graph is above the x-axis. Always positive. This graph is always positive. So we cannot find any graph that is below the x-axis. Less than 0 means below the x-axis, right? Below the x-axis. So we cannot find, okay, so this means below the x-axis. Less than 0 means, okay, use different color. Okay, less than 0 means below the x-axis. So there is no x value such that the graph is less than 0, not below 0. So in this case, there is no solution. Okay, for this one, so let's make it an equation. Then this is x times x, 2 times 2, both negative. So this is equal to x minus 2 squared is equal to 0. Then x equals 2. So this is the x-intercept, right? X-intercept. So let's draw a number line. Okay, 2. So if x equals 2, then y is 0. How about if x is below 2, less than 2? So this one has two intervals. One is less than 2, greater than 2. And then if x is less than 2, let's use x equals 0. Then what is the sign? 0 minus 2 is negative 2 squared is positive, right? So this is positive. If x equals greater than 2, so let's use x equals 3. Then what? 3 minus 2 squared is positive. This is positive. And if x equals 2, then y is 0. All right, then we are looking for what? Greater than 0. Greater than 0. There's no equal sign. So in order for this to be greater than 0, okay, for x equals 2, then y equals 0, right? Y equals 0. So the greater than 0 is what? You know, the positive part. Positive part is all the way from left to right before 2, right? And then all values greater than 2. We don't include 2 because, you know, if x equals 2, then this is 0. So we don't, there's no equal signs, so we don't include 2. So the solution is what? Therefore, the solution is, the positive part is negative infinity to what? 2, and 2 is not included, or starting from 2, not included, all the way to the right. Or you can write it as this: x is less than 2, or x is greater than 2. Okay, this is exercise number 22. Okay, let's find the solution of this inequality. So let's move everything to the left and make it 0. Make it our equation. So t squared minus 15t equals negative 50. That's fine. You can do it this way. So first, we got to find the zeros of this function. Then t squared minus 15t plus 50 is equal to 0. Then t times t. 50 is 5 times t, and both negatives. So this is negative 5t, negative 10t, so negative 15t. Same as the second term. So this is equal to t minus 5, t minus 10 is equal to 0, then t equals 5 and t, 10. So we found two x-intercepts. So plot it on the number line x. So x is 5 or 10. And then when x is 5, then y is 0. X equals 10, y is 0. So there are 3 intervals. So let's find the sign for each interval. This is not x, right? This is t. This gotta be t. So let's use x equals t, t equals 0. Let's use t equals 0. Then let's find the sign of this one, sign. T is 0, then this is negative. T, 0 minus 10 is negative. So negative times negative is positive. So for this interval, x is positive. Okay, between 5 and 10, let's use 6. Let's use 6. Then 6 minus 5 is positive. 6 minus 10 is negative. The product is negative. All right, if t is greater than 10, let's use 11. Then 11 minus 5 is positive. 11 minus 10 is positive. The product is positive. All right, so we know the y value, sign of the y value. Sign of the y value. So we move this one to the left. We move this one to the left, right? So if you rewrite it, okay, let me rewrite this. Okay, t squared minus 15t plus 50 is less than equal to 0. Since this is less than, okay, less than means what? Negative, right? This means negative. Less than means negative. So the less than negative part is this guy. So this interval, when x is between 5 and 10, the y value is less than 0. So the solution is what? X is greater than 5 and less than 10. Or x is what? Use interval notation. Interval notation, then from 5 to 10. Both parentheses. Okay, this is exercise 28. Okay, first let's find the zeros of the function, x-intercept. So in this case, 2x times 2x, 49 is 7 times 7. Then this is 14x. Sum is 14x. The sum is 28x. So the left side is 2x plus 7 squared, right? Squared. Is equal to 0, right? So the x-intercept is 7 over 2. Okay, why 7 over 2? Because we set this one equal to 0, then 2x plus 7 is equal to 0, then 2x equals 7, so x equals negative 7. So x equals negative 7 over 2. So that is the x-intercept. I forgot writing the equation equal to 0. So actually 4x squared plus 28x plus 49 is equal to 0. Then this is equal to this, right? So let's draw a number line. So plot this point, negative 7 over 2. So if x is negative 7 over 2, then y value is 0. Okay, so this expression is equal to 0, right? 0. And we are looking for equal to 0 and less than. So let's check the sign of this y. Okay, let's check the sign of this y for each interval. There are 2 intervals, so let's try x equals less than 7 over 2. So if negative 7 over 2 is what? Negative, like a negative 8 over 2? Is negative 8 over 2 fine? Yes, negative 8 over 2. If x equals negative 8 over 2, then what? 2 minus 8 over 2. So negative 8 plus 7 is negative, but once you square it, this one becomes positive. Positive. This is squared, right? This is squared. So whatever this number is, always positive. So if x is greater than this one, still this will be positive. So all the y value is positive except this point, negative 7 over 2. And if x negative 7 over 2, then y value is 0. So we are looking for what? Less than or equal to. So for the negative, there's no negative values. No negative value. Why? But there is 0, right? 0. So the only solution is what? X equals negative 7 over 2. That's the only solution. Because when x is negative 7 over 2, this equation is equal to 0, right? Equal to 0. There's equal sign, so equal to 0. How about less than 0? For the less than 0, there's nothing, so we select only this one. Right? Or, this is less than or equal to, less than or equal to. So less than 0 doesn't exist, but there exists when this is equal to 0. So when x equals this, then the y value is equal to 0. So that is the only solution. Okay, for this example 5, this is about solving rational inequalities. So let me explain the steps for solving rational inequalities. Okay, first, actually the step is similar to the previous one. So okay, first find all the x-intercept. Okay, find the x-intercept. You know how to find the x-intercept? Set the y value equal to 0. So first we're gonna replace the inequality symbol into equal sign. So the first one is what? Find the x-intercept. So okay, look at this example. X over x minus 2. X over x minus 2 is greater than 0. Then this rational inequality, so change this one into an equation. So x over x minus 2 is equal to 0. Oh, actually, you don't have to make it equal to 0. You don't need it. Let's find the x-intercept. So x-intercept is we are setting the numerator to 0. Set the numerator to 0, then this will be 0, right? So let's say this is f of x. Let's say this is f of x. Then this f of x becomes 0 when the numerator is 0. So number 1 is set the numerator equal to 0. Then this is the x-intercept. Okay, number 2. Number 2 is find the restrict value. So we get the restrict values from the denominator. So set the denominator equal to 0. So x minus 2 is equal to 0, then x equals 2. So we know that x cannot be equal to 2 because if x equals 2, then the function is undefined. So these 2 will not be included anywhere. Okay, number 3 is plot the point. So plot this point, the x-intercept and the y-intercept. So this one, let me change this one into x-intercept. Right? So plot this x-intercept. When x equals 0, then what is y? Y equals 0, right? Y equals 0. And x equals 2. When x equals 2, y is undefined. So when x equals 2, always this should be open circle. The open circle means whatever the inequality contains equal sign or not, we will not include this number 2. And then if x equals 0, then this becomes 0. So in this case, there is no equal sign. No equal sign, so we don't have to include this number as well. So this one has 3 intervals, less than 0, between 0 and 2, and greater than 2. So let's find the sign for each interval. So we have this expression. So let's find the sign of this expression. So if x equals less than, let's say x equals negative 1, then what is the sign? So negative 1, then the numerator is negative. How about the denominator? Negative 1 minus 2 is negative. So the sign of this expression is negative. Okay, if x is between 0 and 2, let's try x equals 1. Then 1 is, the numerator is positive, the denominator is 1 minus 2 is negative. So the sign is negative. Okay, if x is greater than 2, so let's try 3. Then the numerator is positive, the denominator is 3 minus 2 is positive. So the result is positive. Alright, so we are looking for the greater than 0. So y is greater than 0, that means positive interval. So which interval contains positive? Okay, the first one is positive. So there are two intervals that satisfies the inequality. So one is less than 0, the other one is greater than 0, then that's positive. So the solution is what? The solution is, okay, x is less than 0 or x is greater than 2. So this is the solution. Okay, and then we will do some examples later. Okay, how about vertical asymptote and horizontal asymptote? Okay, vertical asymptote and horizontal asymptote of rational inequalities. Rational inequalities. So the vertical asymptote is this. The vertical line. So the graph approaches the vertical line. That's the vertical asymptote. Something like this. So if I draw a graph, okay, 1 over x. Okay, let's say y equals 1 over x. Then the graph looks like this. Okay, so this graph approaches. Okay, so here is y-axis, x-axis. Then the graph is this. If x equals 0 is undefined. So this end of the graph approaches the y-axis but never touch. This end approaches the x-axis but never touch even this one. This end approaches the y-axis but never touch or cross, and this one is same. Getting close to the x-axis but never touch. So we call it horizontal asymptote. This is the horizontal asymptote. And this vertical line is called vertical asymptote. So we can find the vertical asymptote very easily. Just set the denominator equal to 0 and then solve for x. That's the vertical asymptote. Okay. And then the horizontal asymptote, there are 3 cases. In this case, we gotta check the degree of the numerator and the denominator. The largest degree, and then compare the degree. Okay, compare the degree. So if the degree of the denominator is greater, something like this, 1 over x. 1 over x. The degree of the denominator is greater than the numerator. Then the horizontal asymptote is the x-axis, y equals 0. That is the x-axis, right? X-axis. Okay, and another case of the horizontal asymptote is the leading coefficients of the numerator and denominator if the degrees are the same. So m and n are the same. Then the horizontal asymptote is y equals a over b. Just leading coefficient a over b. Very simple. Okay, the third one is there is no horizontal asymptote if the numerator's degree is greater than the degree of the denominator. Then the horizontal asymptote does not exist. Okay, so please understand this vertical asymptote, horizontal asymptote, and understand also how to find this vertical asymptote and horizontal asymptote. And this vertical asymptote and horizontal asymptote are useful to graph rational inequalities. Then what would be the graph of this? What would be the graph of this? Well, actually, not this one. What would be the graph of this? Okay. We can find the horizontal asymptote, vertical asymptote. Okay, this is x-axis, this is the y-axis. Okay, the vertical asymptote is what? Vertical asymptote, you set the denominator to 0. Set the denominator to 0, so that is this part, number 2. Set the denominator to 0, then x equals 2. So when x equals 2, this is the vertical asymptote. Draw a little dotted line. It's a vertical asymptote. How about the horizontal asymptote? Horizontal asymptote is the degree, right? Check the degree. And the degree is 1 and 1. The numerator is 1, denominator is 1. So the horizontal asymptote is what? 1 over 1, right? 1 over 1. vertical asymptote. Horizontal is 1 over 1 is 1, right? 1. So that is the horizontal asymptote, 1. Then the graph, what is the graph? Okay, graph is this. Okay, we know that look, if x is less than 0, then the graph is positive. X is less than 0, the graph is positive. So always positive, so it should be something like this. It should be like this. Should be like this. And this line, this graph approaches the, approaches what? Horizontal asymptote and the vertical asymptotes. And if x is greater than 0, x is greater than 0, then greater than what? Wait a minute, here is greater than 2, then the y value is always positive, right? Okay, sorry about this one. The x, sorry, here's x-intercept too. X-intercept is 0. X-intercept is 0, so we gotta plot, look at this. Let me change this one. So x-intercept is 0, so when x equals 0, then y is 0, right? X equals 0, y equals 0. So the point, the graph should cross this point. Should cross this point. So it's gonna be something like this. Right, like this. So this graph approaches the horizontal asymptote and the vertical asymptote and passing through what? The x-intercept. Okay. And if x is greater than 2, as you can see here, x is greater than 2, then y value is always positive, right? So it's gotta go, the graph should approach the horizontal asymptote and the vertical asymptote. So this is the only place where the graph should, sketched. So this is the graph. So once you using the graphing calculator, your graphing calculator, if you graph this x over x minus 2, then it should look like this. So for rational inequality, we gotta find the vertical asymptote and horizontal asymptote. Vertical asymptote, again, please memorize this information. Vertical asymptote, set the denominator to 0. Set the denominator to 0. That's the vertical asymptote where the graph approaches. Okay, horizontal asymptote, check the degree, compare the degree. So if the degree of the denominator is greater, just like 1 over x, then the horizontal asymptote is what? The x-axis, y equals 0. If degrees are the same, then the horizontal asymptote is the leading coefficient, a over b. And if the degree of the numerator is greater, then there is no horizontal asymptote. So this vertical asymptote, horizontal asymptote is used to graph rational inequalities. And then for solving rational inequalities, please understand these steps. Okay, these steps. So let's try some examples. All right, let's solve this inequality. Okay, first we gotta find the, okay, now set the numerator 0. Set the numerator 0. Then since the numerator is 3, cannot, right? Cannot. How about the denominator 0? Denominator 0 means what? This means 4 minus x equals 0, then 4 is equal to x, so x equals 4. So we have, okay, x-intercept, there's no x-intercept because the numerator cannot be 0. The numerator is 3, always 3. So we cannot make the numerator 0, but the denominator is 0. And denominator is the restrict value, so when x equals 4, that is the vertical asymptote. So we don't allow x equals 4. So there are two intervals. So let's check the sign of each interval, sign of this expression for each interval. So 3 over 4 minus x. So let's find the sign for this. So let's say x equals 0. Okay, less than 4 is 0, so let's plug in 0. Then 3 over 4 minus 0 is 4, so that is positive. Okay, any number that is greater than 4, let's try 5. Then 3 is positive. Okay, 4 minus 5 is negative, so the result is negative. Okay, so for these two intervals, less than 4 and greater than 4, the expression is positive or negative. So we are looking for what? Greater than 0. So we are looking for the positive area, right? So the x values, if x is less than 4, then the y value is positive. So the solution is what? X is less than 4. Or you can write it like this. Negative infinity to 4. 4 is not included. 4 never included, even though there is equal sign. We don't include 4 because if x is 4, then the denominator is 0. 4 minus 4 is 0. If the denominator is 0, then what? It's undefined, right? So we never include 4. Okay, for this exercise number 34, let's find the x-intercept. Okay, the x-intercept is what? Set the numerator equal to 0. So x minus 5 is equal to 0, then x equals 5. That's the x-intercept. How about the vertical asymptote? Vertical asymptote, this is the restrict value, right? So set the denominator equal to 0, then x plus 2 is 0, so x equals negative 2. So we found two x values. One is x-intercept, one is the vertical asymptote. And the vertical asymptote, negative 2 is never included in the solution because if the x is negative 2, then the denominator is 0, then the function is what? Undefined. So never include negative 2, even there is equal sign. Okay, the other one is x equals 5. And 5 is not included because there's no equal sign, right? No equal sign. So the x-intercept 5 is not included. If x is 5, then 5 minus 5 is 0. Then there is no equal sign 0, so we don't include this 5 too. Alright, then there are three intervals. And let's find the sign of this expression for each interval. So if x is less than negative 2, let's use negative 3. Then the sign is what? Negative 3 minus 5 is negative over. Negative 3 plus 2 is negative. So the sign is positive. Negative over negative is positive. Okay, how about the between negative 2 and 5? Let's say x equals 0. Then x equals 0, then what? 0 minus 5 is negative. And then 0 plus 2 is positive. So this is negative. Negative or positive is negative. Okay, what if x is greater than 5? So let's try 6. Then 6 minus 5 is what? 6 minus 5 is positive. And then 6 plus 2 is what? 6 plus 2 is positive. So the result is positive. Now we are looking for what? Less than 0. Less than 0. So the negative part. So if x is between negative 2 and 5, the y value, the expression is negative, right? So that's the solution. Do we include negative 2? No, never ever, because negative 2 is what? It's the vertical asymptote. How about 5? In this case, no, because we don't include 5, because there's no equal sign here. So the solution is what? X is between negative 2 and 5. Or you can write it as negative 2 to 5. Endpoints are not included. Okay, this exercise has inequality, equal sign in the inequality, right? Equal sign. So we will include negative 1 as well. Okay, in this negative 1, okay, let's make it, okay, let's move negative 1 to the left. Then plus 1 is greater than or equal to 0, right? And then let's combine these two. Let's combine these two, then what? 2 over x minus 3 plus, okay, 1 is what? X minus 3 denominator, then the numerator is also this one. then this is equal to 2 plus x minus 3 over x minus 3. We are just rewriting the inequality again, just rewriting. Then x minus 1 over x minus 3 is greater than or equal to 0. So finally, this original inequality became this. Okay, this is important. So make sure one side of the inequality is 0, and the one side is rational expression. Okay, in this case, when you simplify this, don't multiply this inequality. Don't multiply this inequality by x minus 3. Don't multiply. Just move -1 to the left and then simplify. Okay, so from here, okay, now set the x-intercept. How do you find the x-intercept? Set the numerator equal to 0. Then the numerator is what? X minus 1 is equal to 0, then x equals 1. So this is the x-intercept. And the vertical asymptote, we set the denominator is equal to 0. So x minus 3 is equal to 0. Then what is x? X equals 3. So this is the vertical asymptote. This is the x-intercept. So plot these 2 points on the number line, x equals 1 and x equals 3. All right, so one is the what? One is x-intercept. So if x equals 1, then what happens? Y is 0. So in this case, since there is an equal sign, there is equal sign, right? Equal sign. Equal sign, we will include this number 1, x value 1. Because if x equals 1, then the y value, the expression is 0. How about 3? If x equals 3, that is the vertical asymptote. So never ever include this number 3. Okay, number 3 is not included. Open circle. So there are 3 intervals. 3 intervals. So why don't we find the sign for each interval? Okay, sign of the expression for each interval. So let's say x equals 0. Less than 1 is 0, right? Then what? 0 minus 1 is negative. 0 minus 3 is negative. The sum is positive. So the expression is positive when x is less than 1. How about between 1 and 3? So let's try x equals 2. Then 2 minus 1. The numerator 2 minus 1 is positive. The denominator is 2 minus 3 is negative. So the sign is negative. Okay, what if x is greater than 3? Let's say 4. Then the numerator x minus 1 is, okay, 4 minus 1 is positive. The denominator 4 minus 3 is positive. So the result is positive. Alright, so there are 3 intervals, and for each interval we found the sign of the expression. And the expression is what? Greater, right? Greater than or equal to. Greater than 0 is what? Greater than 0 is positive. So we have 2 intervals where the y value is positive. Right? So when x is less than 1, y is positive. When x is greater than 3, y is positive. And if x equals 1, then y is 0. If x equals 3, then y is undefined. So we don't include these 3. So the solution is x is less than or equal to 1. Or, in this interval, x is greater than 3. There's no equal sign here because we don't include 3. So we can write it, the solution in an interval notation. So negative infinity all the way to 1, and 1 is included, so use the bracket, or is u. And then x is greater than 3, 3 to infinity, and infinity is parenthesis. 3 is not included, so put parenthesis. Okay, so this is important. So if the inequality contains equal sign, then we include the x-intercept, but do not include the vertical asymptotes. Okay, so this is important. All right.